Hey guys, welcome to my series of videos where I'm solving LeetCode problems, starting from the easiest ones, going to the hardest ones. And I'm solving them from scratch, but I really got stuck on something. And I was trying many things. I even came up with this. So these are the different ways of doing this exercise for the argument 4. So let's look at the climbing stairs problem. So if you're climbing a staircase, it takes n steps to reach to the top, but you can either climb one or two steps in a row. And how many distinct ways can you climb to the top? And I was trying different things, so I'm just going to take some steps back and try it again. So let's say we have 3 steps. Here are my 3 steps. There are 3 ways to do these steps. One way is 1 step at a time. Second way is 2 steps, then 1. And then the last way is just 1 step and then 2 steps. That's it. So one way we can do this is I think we can divide the problems and use recursion. And the way to do it is like this. The way to solve the number 3 is to solve 1 plus the number 2 and then 2 plus the number 1. So if we climb 2 steps, it's just one way, and then we just deal with the rest. I think it's 1 times this last one, the 1 step. And the second thing, if we just do 2 in a row, it's also, no, actually, if we do 2, it's 1 way times 1 step. And then if we do it, just 1, it's 1 times the solution to 2 steps. So let's see if this works. The solution to 1 step, let me just increase the size. Solution to 1 step is 1. Solution to 2 steps is 2. Let's see. So the solution to 3 steps must be 1, the solution of 1. Solution of 1 plus the solution of 2. If this works. Guys, I was completely going off the rails. I was importing factorial, log. I was going all the way. But I started simple. I started with this. And it wasn't really working. So return self dot climb stairs of n minus 1 plus self dot climb stairs of n minus 2. And if n is smaller or equal than 1, return 1. There's 5 ways to climb 4 steps. Okay, this works. You have no idea how long I stayed here. Because I tried the simple things, but it wasn't really making sense to me, and I just completely derailed. So if you guys don't know recursion is when the function calls itself. Okay, number 44. Time limit exceeded. Actually curious to see what 44 is. Oh, it's actually taking forever. 3 minus 1, 2. So 2. 2 minus 1, 1. I think I just need to wait. I don't get why this is running forever. I climb stairs and n is 44. So now, oh, I need to do it like this. So n is 43, n is 42, n is 41. So I can just conditional breakpoint n equals 5. N equals 5, so n equals 4. You can see it on the top. N equals 1. Okay, it just takes a long time, I guess. N equals 39. Let's see if it stops at any point. Okay, it's taking forever, and there's a way we can optimize this. Okay, so save values. It's going to be a dictionary of ints and things. Okay, cool. So climb stairs, save the values. So val1 is this, val2 is this. Return val1 plus val2. So if n minus 1 in save values dot keys, you can just say that val1 is equal to save values of n minus 1. Else, we need to calculate it. And now the same thing for val2. N minus 2, 2, 2. I just want to print n so I can see if it's going depth first, because that's the important part. It's going depth first. Mm, Actually, it's going depth first, but it's not really doing what I wanted, because it's still going to calculate all of that. Let's see a different way. We can do it the opposite. We can start with, let's do it this way. Mm, I in range n plus 1, of course. Let's try to iterate all over until we get, actually n is enough, till we get to where we want, and then we just return the value. So for I in range n, this is weird. I want to save time. I don't want the same thing to run twice. So I need to go all the way there. So if I minus 1, not in, no, I minus 1, not in save values dot keys, find value of of yeah, I minus 1, val 1. Oh, no, this is stupid. Because 1, I know that 0 is 1, 1 is 1. So val 1 must be, it has to be there. Now, if not there, then val and saved values of I minus 1 equals, no, if I not in value, saved values of I equals saved values of I minus 1 plus saved values of I equals 2. Then we just do return saved values of n. How can we go? 44, saved values of 44. Just running the test cases. Yeah, submit. Okay, it works. Beats 47 and beats 98. So if it wasn't clear, well, now it beats 52. Yay, green lights. So if it wasn't clear on why this is better than using recursion, is that if you use recursion, then you end up going all the way to the bottom, and then you need to do all the bottoms. So there's no way of saving the values. Where there is a way to save the values, but it's not worth it because you're still going to, even when you save the value of uh, the number 4, there's still going to be number 4s and number 3s being calculated. So it's not really worth it. It doesn't give you such an advantage. Might as well go bottom up instead of top bottom. Well, I hope this helps.